are, just summarizing very quickly, a change of 0.02 in y, 0.02 in the value of t, where t is equal to pi, predicts a change of delta y about 0.003. So in our graph of z versus x versus y, or y versus x, whichever way, in our xyz plane, down here in the plane we have a change in y of 0.003, which combined with the slope that we get from the partial derivative with respect to y predicts a change of 0.003 in the value of y due to the change in the y direction. Then using a change in x of 0.0002, which doesn't quite fit the model, but I wanted to have some kind of a change here. And this is the actual change in the value of x, at least the approximate actual change. Because again, the change in x based on t equals pi, based on the derivative of t equals pi, would be 0. So I used the kind of the actual change in x, the difference between these two values. We got a difference in x of 0.002, which drives a change in the value of f due to the slope, the partial derivative with respect to x of the function in this plane, in an xz plane through this point, plane parallel to the xz plane through this point. So we call these changes delta z hat and delta z tilde, and we say that because these are small intervals of x and y, the slopes aren't going to change all that much, so that the rise we get from here to here should be about the same as the rise we get from here to here, because this slope should be very close to this slope. So using this slope with this x increment, this slope here with this y increment, we get this total change in z. Okay, now, what approximations were made and what's the significance of those approximations? Of course, we fudged over here, so we don't want to talk too much about this, but let's look what happened with y. Okay, we didn't fudge, we used, for our delta y, we used our y prime times delta t. And of course, if we had used this accurately, we would have gotten 0.003183. I said it would be close to 0.0032, because of course doubling this is pretty close to 0.16. So our delta y should have been, and to be completely accurate, 0.00, well, that wouldn't have been completely accurate, but using this prediction with all the significant figures, we would have gotten 0.003183. So if we wanted to make a more accurate prediction in the change in the value of f, we wouldn't have used 0.003. We would have calculated this out to more significant figures using 0.003183. Now the actual change in y due to a change of 0.02 in t is easily found. We evaluate y at pi, which we've already done. We evaluate y at pi plus 0.02, and we get this. Well, we don't get this, but if we take the difference, y pi plus 0.02 is about 0.696, y pi is about 0.693. The difference is about 0.003, which of course agrees with the approximation we used here. If we carry these calculations out to more significant figures, we find that the actual difference between y pi and y pi plus 0.02 is about 0.003178. The difference we predicted based on the derivative at the t equals pi point was 0.003183. That's a difference of 0.000005, about 5 parts in 3,000, less than 2 parts in 1,000. So there's a slight difference here, which means that when we do this differential approximation, which is what this actually is, we're not going to get the delta y quite right, okay, by using the differential approximation, the approximation based on the value of y prime at t equals pi. And the reason for that is clearly that y prime actually changes between here and here. There's some slight curvature, not a straight line, but we aren't off by much. We're only off by 1 part, less than 2 parts in 1,000 for our average slope. It was going to give us a very tiny discrepancy in this value out, several more significant figures. So we make that comparison, and we can actually then do this a little bit more rigorously, in a little more detail, but this is as far as we went with it. So here's the actual difference between the slope prediction and the change in y. There's the difference. Okay. And we conclude, as we did in preceding videos, that the change in z is fy delta y plus fx delta x. That's our approximation. Again, what we're doing over here is just looking at what small discrepancies there might be in this approximation. And then, since delta y is dy dt delta t, this approximation, y prime of t delta t will be dy dt delta t, and fx times delta x, fx times dx dt times delta t. If we divide both sides of this by delta t and divide delta z by delta t and take a limit, we get dz dt equals dz dx dx dt plus dz dy dy dt, where fy is represented over here as dz dy and fx as dz dx. Now, all this is done more coherently because we didn't have this necessity for approximation in the preceding videos. So kind of apologize for being a little incoherent with this video and the preceding, but hopefully you've viewed the videos that preceded all this and understand quite well what's going on. This is what was actually done in class.